All right, so in this video, I wanted to show a few special cases where either I've, historically used comprehensions a lot, or I have been tempted to use comprehensions and perhaps there's a better way. But definitely just want to kind of go over, so there will be three in this video, and then there's actually one other special case that I am going to show in a separate video because it could take a little bit of time and I would like to have it kind of in its own separate thing. All right, so the first case that I am going to cover is flattening a nested list. All right, so what is shown here, let's imagine I've got this list object, and it is, in this case, we've got three elements. So I'm just going to hit enter to run that. So if I were to get the length of my list, there's three elements. And then if I were to grab one of those elements out, we can actually see that it is itself a list with three elements. So it's like a matrix, right? We got 3 by 3. And sometimes, we might get back a data structure like this from various reasons or for various reasons. And what we might want to do is just get a nice flattened kind of one-dimensional list. In this case, since we got a 3 by 3, maybe we just want a single dimensional list with 9 elements in it. So let's see first off how we could do that with just kind of a long form representation. So what we might do if we want to achieve this, so I'm going to call this flattened weights, empty list, and I'll say for row. So this is going to iterate through each one of these lists that are stored in the rows. So I'll say for row in weights, and then I'll say, okay, for weight in row. So what I'm doing, this first loop again is grabbing each one of these sub-lists kind of independently, and then the sub-list, or when I iterate over that, I'll be getting those individual weight values. So for row in weights, and then I'm getting the individual weights from each row, and then I can just take those flattened weights and append whatever the current value of weight is. And let's just copy that down. All right, so when we run this, we can see that we've got our first row, 1.25, negative 0.41, negative 1.4. Those are our first three values. Then it goes down to those weights that would have been in that second sub list, like the second row of our matrix, are in positions, essentially index positions, 3, 4, and 5, right? Remember, starting at 0, 1, 2, so these are 3, 4, and 5 on the index positions and so forth. So this is doing what we would expect it to do, right? We can do this in a comprehension style. All right, so let's see what that would look like. So I'm just going to initialize my object. I'll put a underscore LC at the end of that. And then what we'll do is, what do we want to store? That needs to come first. So I want to store weight. All right. And what you need to do is you'll just walk down this structure in essentially the same order. So I'm going to store weight for row and weights. All right. And then for weight in row. All right. So that would do it. So we're just working from those outermost loops. And then, so it's always, kind of looking at that outermost to the innermost when you're doing this flattening type of move. So we'll run that, and we've got our flattened weights. All right, now if you get this order wrong, so it can be a little bit confusing. Should I work from inward out on those nested for loops, or should I work the other way? Just to show you, Python will complain if you get it wrong, right? So let me restart this kernel, and I'm just going to run that first cell, get the weights here. Now what if I had gotten that out of order? So I'm going to do for weight in row. So I'm working on this inner for loop, and then I'll go to this outer for loop for row and weights. All right. And then, so when I run this, we're going to get an error. All right. And it says, hey, I don't know what this row thing is. Right. So if we think about kind of the logic, if we're going from left to right, we're saying we want to do weight for weight in row. Well, at this point, we don't know what row is, right? So we've never encountered anything in that preceding. So you got to remember, as it's parsing this syntax, it's working left to right. So at this point, it's never seen us use row before, and that's something that was not defined. All right, now let's restart that kernel one more time. And let's reverse the order to the correct order. All right, so why is this any different? All right, so we go, remember weight, so that's what we're wanting to store. So Python recognizes, well, that's the thing that we're going to place there, so that definition will be coming. All right, for row, so this is my loop variable in weights. All right, so remember we previously had row here, but has Python seen weights before? Well, it has. We defined it up here. Right, so that's why this is going to work. So for row in weights, it says, okay, well, I know what weights is. I'm going to grab those rows, and now for weight in row, and that will work. All right, so that is how we can flatten a nested list with a comprehension. Again, you might argue that, well, the readability, I got to sit here and really think about what's going on. So, of course, if you prefer kind of this more verbose format, I encourage you to do that by all means. Whatever is easier for future you to kind of interpret, by all means do that. All right, so that was essentially flattening a list or a nested list. And I'm going to delete that just to reduce some clutter, restart my kernel. There we go. All right, so another use case that I tend to, or am at least tempted to use a comprehension for, and especially their ability to filter, is to find common elements in list. All right, and to kind of motivate this, I'm going to use some random numbers. So I'm going to import the random library, and then I'm going to set the random seed equal to 0, just to make sure that we are all seeing the same numbers. And I'm going to create two lists of random numbers. So I'm going to say random number list 1. And that is going to be, I'm going to do random.rand int. And let's just say I'm going to go from negative 10,000 to positive 10,000. All right. For I in range, I don't know, let's do for I in range, let's just do 100 at this point. Let's actually narrow that range up for this demonstration. So just let me do 100 right here. And then we'll go to 100 there. All right. So that's going to be my first list. All right, I'm using actually a comprehension here to build this. So this is, I'm going to store just a random number between 100 or negative 100 and 100. And I'm going to have 100 of those. All right, I'm going to just copy down that code and make a second list. All right, so if I were to print random list 1, this is going to be fairly long. All right, you can see we got a bunch of random numbers here, right? And in particular, if I look at the length of these, we've got 100 of them. Now, suppose that we have, maybe 2 lists of customers, right? And we're trying to figure out, maybe each one of those lists is containing customers that bought a specific product. And we want to figure out which customers bought both products. So we want to find which customers are represented in both lists. That's very similar to the task that I'm illustrating here. It's just I'm trying to figure out which numbers are represented in both of those lists, if there are any, right? We don't know that there are any. All right, so what you might be tempted to do is do so let's actually do it long form first. All right, so let's say common numbers. All right, and what we could do is we could say, well, for number in random number list 1. All right, we'll say if, all right, that number is in random number list 2, what we'll do is we will append that to our common numbers. All right, so this first for statement here, or the only for statement, is we're iterating through those numbers in list 1. And then in the next line, we'd have a conditional, which checks to see if that number is also in that list 2. If so, we append that. All right. All right, so we've got our common numbers. Let's see how many there are there. Let's see if all of them are in there. All right, so 45 out of those 100 generated for both are in there. Now it could be, I'm just going to take a real quick look at this. One thing that we need to note is this might not be entirely correct. So if I were to do sorted, that will actually sort that list. Right. You can see some of the numbers are repeated, like negative 77 appears in that list. So yeah, I mean, technically, I guess that's not incorrect, right? I mean, negative 77 is definitely one of the common numbers, but maybe we don't want repeats. So what we could do at the very end of that is say common numbers equals set common numbers. And that's just going to get the unique values. And there we go. All right, so now we've got one entry, and we can see that, in fact, how many of those are in common? Only 33. All right, so that's kind of our long form for doing that. And let's think about how we would do this with a list comprehension, right? So it's actually pretty straightforward, right? So we would have our starting right there. And then we could say, okay, what we want to append is number, all right, for number in list 1. And then we have our filtering conditional at the end. So in this case, we're using this to filter the things that actually get added. So we could put that at the end. And then this is going to say, well, okay, we'll only include that number if this filter evaluates to true. And that filter is that number is in random number list 2. All right, so if I look at the length of this, right, there was 45. And the reason was, as we recall, if I do sorted, right, some of those numbers get repeated. So maybe a list comprehension is not the best type of comprehension for this, right? So instead of a list comprehension, we could make it a set comprehension and say, well, only give me those unique values. And there we have it. All right, so now we've got that filtered list. So we went down from this right here where we're having to use a set. We went through and said our common numbers, we built a list, and then we converted that to a set. All right, so that is a different way of building that. All right, I am going to show you though, because of this looping structure, let's see if we can make this just a little bit more efficient. So I'm just going to run a time it here. So we'll time it. Let's see how fast that runs. All right, so maybe I'm going to make let's make these number lists a little bit larger. So I'm going to make them both 10,000 random numbers, and then in this case I will kind of that's fine. There's going to be a lot of repeats, so let's just see how this runs. All right, so 201 common numbers there. We do a time it. This should take a little bit longer. Hopefully we'll see a little bit more meaningful differences. So it took 7.47 milliseconds. All right. Let's look at a different way of doing this. All right. So one thing that and this can oftentimes, so I'm kind of interested in, they've been changing this. So the core developers of Python have been putting in a tremendous amount of effort on ways and optimizations to make Python faster. So the differences that we see here in timing might not be as substantial as they once were, but it used to be fairly significant because this was kind of a common thing that people want to do. We want to find common elements among two. And you can already see that we've kind of went to a set comprehension, but we're still operating on these lists, right? So if we think about for number in random list 1, well, random list 1, that is a list, right? So we see braces here. And then we're checking if number in, well, that's still a list, right? So we're checking is something in a list. All right, what we could do is if we've got our random number list, what we could do is we could just make it a set. All right, so I'm going to say this is going to be my random number set 1. And I'm just going to wrap our list in a set and do a conversion. So we're going to have our set 1 and set 2. So these things are now not lists, and they might not have 10,000 objects, but remember the task that we're trying to do here is trying to find numbers that are in common, right? So we've done this conversion to a set, and a beautiful thing, so if I take the type of that random set 1, it is in fact a set. All right, same thing for set 2. All right, the nice thing about sets are they have a method called the intersection. All right, so if you're familiar with set theory, the intersection of two sets are the elements that they have in common. All right, so now we don't have to do this for and if type of lookups on list. We just do a conversion to set, and now I can say, well, give me back the intersection of set 1 and set 2. All right, so this is just printing it out. In this case with my numbers here, because I've generated a lot, apparently, we get back all of those numbers, but this will perform exactly the same operation. All right, so I'm going to say this is going to be my common numbers is now going to be a set. All right. So this is going to give us exactly the same thing. The key thing to note is right here, right? We were doing a set comprehension. So let's run this. Let's make our values a little bit so it's not likely that everything is common. So let's make this maybe 25,000 to positive 25,000. Otherwise, we end up with, if we generate 10,000 random values between negative 100 and 100, all those values are going to be in there. All right, so let me do a restart, clear all outputs. We'll go from top to bottom. All right. Let me just run this without the timing first. So let's run common numbers there. And I'm actually going to call this common numbers 2. Right, or yeah, 2 would be fine. All right, so that should be good. What I want to make sure is common numbers, are the values equal? Let's see if we can check for equality of sets. It's true, so both of those things are returning exactly the same thing. All right, let's do our timing now. All right, so I'm going to run my timing here and my timing here. All right, so you can see that this is significantly faster to do using sets, right? So even though I've got 2 additional assignments here where I'm creating new objects and setting them equal to a set, right? When I'm doing this intersection, so we got 608, I guess, microseconds here versus 431 milliseconds. Let me, sometimes it's hard for people to convert from micro to milli, so let me make this just a little bit bigger. So let's do 100,000. Let's get these up all both in hopefully the millisecond range. Much bigger loops. Maybe I was a little bit ambitious. I'm going to restart one more time, and instead of doing 100,000, I'm going to kind of meet in the middle here. Let's do 25 or 20,000. I want to see how long that cell takes. Okay. Let those both run. All right, so that took 1.57 seconds per loop. It did 7 runs of 1 loop each. And let's see what our set-based implementation. So 1.18 milliseconds versus 1.57 seconds. So that, that would be 1,570 milliseconds. So let's do 1.18 divided by 1,570. So it took less than, 1% of the time. So that's significant, right? So I see a lot of times, people are doing loops where they're having to do this multiple times and they're checking for common elements. And this can literally be the difference from your loops taking days to run versus taking, minutes or even seconds to run. So this is a big one, right? Not a lot of people kind of realize. And again, it kind of goes to this notion of, a lot of times Python gets historically, I think this is becoming much less of the case as the core developers work to speed things up. People say, well, Python is slow. Well, yeah. Python can be because it's kind of an interpreted dynamic language. can be a little bit slower. It's never going to beat the raw speed of, say, of C++, but it can be competitive. It can be fast enough for applications. Again, Python is kind of the language that I use in many large-scale projects, and it is performant. But the key thing is you've got to recognize kind of the strengths of Python and recognize the differences in data types. So if you write Python code like you would C++ code, well, yeah, you're probably going to run into some speed issues. But if you recognize, like in this case, the way that sets are implemented allow us to do this intersection and do that very quickly, you can get some real speed ups and highly performant code. All right, so the last little special case I wanted to do in this video is one thing that I do very frequently with dictionaries. So a lot of times I might have, some type of a string or some other types of objects, and what I need to do is come up with a way to map those objects to an integer. So basically, imagine I've got a list of names, and I need to go back and forth of being able to access those names by the name itself or by their index in that container. So a lot of times I will create mapper objects. And again, if I'm using like pandas data frames, which there'll be more videos on pandas and others, I might use these mappers to go relabel columns in a data frame to make it go from a string to an integer for maybe data storage or reducing storage space. So I wanted to show you that real quick. It's pretty simple. So let's say that I have a list of names, and I'm just going to say, let's say Debbie. Let's do Gabrielle. Let's do Alice. And let's do Frank. All right, so maybe I've got this list of names, and what I want to do is get them into, some type of indexed structure where I can go back and forth and figure out which name is at which position. And then if I give you a name, I can get the position back. And then also if I give you an index position, I can go get the name. All right, one thing I like to do whenever I'm kind of doing this use case is the first step is I will sort that object. Right, so in this case, I might take names initially and immediately sort that. Right, so now if I look at names, they're going to be sorted alphabetically. All right, so sorted does that. If you did for some reason want to do that in reverse, there is a reverse keyword argument that you could say, let's do that true, and we get them in reverse. All right, but I'm going to go ahead and sort that, and then what I would tend to do is I would use a dictionary comprehension along with enumerate to map these values to their index positions in a dictionary. All right, so what I would typically do, and this is just a thing that I like to do, so this is kind of how I name things. So I would do something like index to name mapper. All right, and what I'm going to do, so this is going to be a dictionary where I've got index values that map to a particular name in this list, and in particular this sorted list. So Alice should be in index 0, Debbie in index position 1, Frank in 2, and so forth. All right, now remember, we want to do a dictionary comprehension, so the thing that we want to store is going to be a key and a value. All right, so if you remember in the videos where I was talking about flow control, we looked at this enumerate built in Python. So if we take enumerate, all right, so what it takes, you give it an iterable and a start position, and it's going to give pairs containing the count from start and the thing that you the objects in the iterable. Right, so just to kind of show you, let me comment this out real quick. So if I say, for index name in enumerate names and print that, let's print index and name. All right, so I'm getting back the index. So Alice is in position 0 of that sorted list, Debbie in position 1, Frank in 2, and so forth. So the key thing is this is giving me back two things, right? So remember, with a dictionary comprehension, we need two things, a key and a value. So we can use this immediately. So we've got this loop written out. So I'm just going to kind of transpose this or just translate this into my dictionary comprehension. So I'm going to take index and name, put that right at the beginning. Let's just do that. I'm going to use a colon to separate. indicating that there's a key and a value. And I need to do this for index name and enumerate. All right. So this is now our dictionary that maps from index position to name. So if I said, okay, well, who's in position 1, right? That's Debbie. And again, you might say, well, gosh, I could just index the list and get position 1 and so forth. And that's true. But again, having this mapper format is going to be very helpful when we start working with other libraries, in particular like a pandas or a polars, because we can use them to essentially in one, vectorized kind of operation, replace values in a column based off of some other value. So this is going to be really helpful to have it in this dictionary format. So a lot of times when I'm doing this, I like to create the mappers both ways. So I've got an index to a name or an object, and then I'll do the opposite, which is the name to the index. So if I look up, I can provide an Alice and it'll tell me what position it is in that array. And once you build one, you just reverse it for the others, right? So instead of index to name, I'll say name to index. All right. I'm going to flip my key and value. All right. All right. And this is going to essentially do the same thing in reverse. All right. So now they were both built off of the same object. So we see up here in our index to name, we've got index 0 is Alice. Well, here when we look up Alice, we can go to 0. All right, so that is going to be the last special case in this video, and there's going to be one additional video focusing on another special case that has to do with comprehensions, or that I tend to use comprehensions for, and that is sorting dictionaries by the values, not the keys, but the values in that dictionary.